Take over.
All right, thank you. I am a little concerned about my internet because the audio is getting a little clippy. So if at any point it becomes unbearable, let me know and I will go like be away for a few minutes and like restart my internet or something like that. But hopefully we'll be able to make it through just fine.
Sounds
I'm
good.
organizing my screens and everything. Okay. So thank you all so much for joining tonight on a talk on project-oriented workflows. You'll see this little hex down here that says WTF. That is what they forgot to teach you hex. So this is part of a larger workshop called What They Forgot to Teach You About R. And this is one portion of it. So what we're going to be talking about today is how you're going to be organized in your projects. You're going to get a practical example. We're going to talk about what it means to be an RStudio project and what's so special about it and how it can help you be more efficient with your workflows. We're going to talk about how you can construct safe paths utilizing some properties of your RStudio project and otherwise. We're going to talk about naming conventions, and if we have time, we'll get to project structure. So this content does typically span about 2.5 to 3 hours live. So we might not get to all of it today. If you at any point you have questions, please feel free to drop them in the chat. I'll be pausing frequently, so you're welcome. We can address them right then if it's appropriate, or we can address them later at the end of the workshop as well. We can also have some offline time at the end of the workshop that's not recorded for questions that you might want to ask that aren't recorded as well. So let's get started. This work is under a Creative Commons license. And you are going to be working from your own personal computers if you are following along and doing the activities with us. So I'm going to be assuming that you have R installed and it's a pretty recent version, like greater than 4.3.0, and that you have a pretty recent version of RStudio. And then the packages that we are going to be using in this workshop are Tidyverse, R Markdown, use this, FS, and here, and I'll drop. Well, I thought I was dropping that in the chat. And drop something else in the chat. There we go. Yeah, so that's in the chat now. This does go along with a book. So there is the rstats.wtf book, which has been authored by Jenny Bryan, Jim Hester, and David, and I have been very slowly starting to make contributions to this book. But this is another reference you can go back to for more information. So let's talk about how you are going to be organized in your projects. And actually, just kind of to take it one step back, because we do have some intro slides that precede this set. When we're talking about what they forgot to teach you about R, we're assuming that you are here because you're interested in some level of data analysis, whether that be statistical or otherwise, and that you enjoy working with data and you enjoy programming. And you may or may not have had some sort of like formal curriculum around programming in R, but we find that there's a lot of holes that people fall into, a lot of gaps where you might have learned how to wrangle data, but not necessarily how to organize a project, or you might have learned how to do a statistical analysis, but like not really best practices for naming things. So that's kind of like what we're here to talk about, these kind of gaps to fill in that aren't traditionally part of a curriculum. So what did they forget to teach you? I guess this was the slide I was talking about. They taught you data analysis or statistical analysis, but then there's everything else that goes around packaging this up in a tidy and efficient way that sometimes gets forgotten. Some of the other components of this workshop include personal R administration, debugging, version control with Git and GitHub, and I think there's one more section that I'm forgetting right now, but other things that people have forgot to teach you. So let's do some deep thoughts. we all have projects that we have worked on in the past that perhaps haunt us. And we're not here to suggest that you go back and rework all of those projects. I think it's a best practice to be organized as you go. And not tomorrow, not to put it off for another day, but just to kind of make this intentional start right now, that I'm going to like make a few incremental lifestyle changes that are going to carry me forward into the future. We're not going to worry about our past mistakes. We're gonna shut those doors as long as they don't come back to haunt you, as long as they're like not actively giving you friction. Like just shut the door on those past projects or keep them running on life support. But as you go, we're going to raise the bar for new work and kind of help you with some strategies, practices, and workflows that might make new work go smoother. And so when we talk about being organized, we want to kind of create a project that's self-evident, that the way it's structured, the way it's named, the way everything goes together is like self-explained, like it's self-evident when you look at the project structure. And that's going to be a lot better than if you have like a really long, in-depth, wordy README that tells you exactly what steps you need to go through in order to achieve some sort of data result. And so when we're talking about being organized, we want like a really nice, tidy structure for our project. Maybe all of your R scripts fall under an R folder, which if you're not familiar with like package conventions, that is a convention when you're creating R packages that your scripts go in an R folder. You might have a data folder that where your data lives, a figs folder where you create your figures, but it's got a consistent structure across projects and it's self-evident. And that's going to be way better for you in the long run than some sort of file salad where everything is mishmashed at the top level and some sort of README that needs constant modifying and updating every time you make a update to your project structure. And there is a paper out there called Good Enough Practices in Scientific Computing. So maybe if you're in an academic environment and you need some sort of evidence to present to your supervisor as why we might be angling for this sort of thing, you can go to reference this. It's in PLOS Computational Biology, and that's by Jenny Wilson and others as well. And we're talking about good enough practices. We're not actually talking about best practices. We're not aiming for this trophy that may or may not be attainable. We're aiming for something that makes our project more humane and more livable and more shareable for us. And if you can see, what is that on the wing of the airplane there?
Duct tape.
It's duct tape. So right, like we just need to get the plane off the ground. We just need the project to fly. Sometimes it might take a little duct tape. It doesn't have to be perfect. It has to be good enough. So let's talk about a practical example, which relates to some of the larger portion of the content in this 2-day workshop, which is about your personal R administration. So if you don't know it, you can actually dig into your own R installation and figure out what packages you have installed on your computer. So when you're thinking about R packages, it's like the natural unit for distributing R code. Base R, like when you just install R out of the box, it does actually come with what we call 14 base and 15 recommended packages. And these come every time you install or update R. So that's 29 packages you get by default. And as an example of one of these packages that you may or may not have heard of, there's a package called Lattice. And if you check your R installation right now, you will find it in your list of packages because it comes in as one of these recommended packages. So regardless of whether or not you use it, it is installed on your personal machine because it was installed as a recommended package. And this is a package for graphics that preceded ggplot2. But of course, you can get additional packages beyond those 29 base and recommended packages. So on CRAN, there's like, last I checked, like close to 20,000 packages. And so you can install packages from CRAN using install.packages. And you can attach those using library. And then of course, not all our packages out there are housed on CRAN. So there's many, many more packages that are housed on other places like GitHub. And who knows how many additional R packages there are. So one way you could install a package from GitHub is using DevTools install GitHub. And we can investigate this on our own machine. So where do packages live locally? They do live in your default library, which you can recall using .library. You can also recall or find all libraries for the current session, which may or may not be the same as your default library. So .libpaths will return all available libraries for the current session. There may be reasons why that is the same or different from the result in .library, or why you might have more than one library available in your current session. And you can also retrieve all installed packages using the install.packages command. Before we get into our first exercise, and by the way, we're almost at our first exercise, you're gonna look at your own packages. I'll just do a little syntax aside. So in some of the exercises, you might see something called a pipe. As of 2014, there was something called the McGritter pipe, which is the % greater than % pipe. And then in 2021, the native R pipe was introduced with that's compatible ships with base R. So you're going to see the native R pipe in my code. Hopefully I've made all the updates everywhere. If you find any that need to be updated, let me know. And then you're going to read the pipe as and then. So what the pipe does is it takes the first argument of a function and it allows you to say, take arg1 and then do whatever with arg2 and arg3. So as an example of the mean function, we're going to take the vector of numbers 0 through 10 and then take the mean of it. If you are still using the McGritter pipe and you're interested in switching over to the native R pipe, you can actually change the shortcut on your RStudio interface. So you can change, if you use the Control-Shift-M shortcut, you can change that to be the native pipe instead of the McGritter pipe. And those instructions are down here. Another thing that you might see in our code is namespacing, and namespacing refers to the colon. So we're doing package : function. And this is telling R explicitly to use the select function from the dplyr package, which can help you avoid name conflicts. So for example, the mass package also has a select function, which does something very, very different. And it does not require you to submit library dplyr if you are namespacing that function. So here's an example of how you could do the same equivalent code with namespacing if you're not familiar with that syntax. Okay, it is time for our first exercise. I'm going to give you all 10 minutes to explore your R installation. So this is going to require the use this package, and you're going to use course rstats-wtf /wtf-explore-libraries. Now, before you execute this, by default, I want you to know that this is going to go probably to your desktop. And if you want it to go to some other destination besides your desktop, you just need to supply this destdir argument, and you can specify the path where that should be downloaded to. Or you can alternatively download from GitHub. Just for a quick example, I'm going to open up the GitHub link just so you can see what you're going to get into, and so I can orient you to the exercise. So all you're going to see here are 3 R scripts, and it's going to open up on your computer, and it's got a README file. And the 3 R scripts say to choose your own adventure. So there's the Spartan script, which is directions to explore without suggested code. The Comfy script is directions to explore with suggested code. And the solution script gives you directions to explore with code solutions. So just kind of depending on what level of challenge you're feeling at this hour of the day, go with whichever script you feel comfortable. And I will give you all 10 minutes to go, and you are welcome to drop any questions in the chat. If you're use course, and it's asking you if you want to delete a zip file, you can go ahead and say, yes, we agree to do that.
in case you missed it in the chat, if you finish with the exercise, drop a thumbs up in the chat to let us know.
Did the audio go through on the timer? Did everyone hear the? Oh, okay.
No, I
I
didn't.
couldn't tell if that was what people were laughing about. It's like a little like video game thing sound.
I was
Maybe
laughing at Megan's number of packages, but
yeah. So there was one participant in the chat who says they have 6,000 packages. If you look at installed packages, it does kind of create this interesting object that kind of looks like a vector, but it's not. So I recommend converting that to a tibble, and then you'll kind of get a that I think it's like 6,000 data points you have about your packages, not.
No, it's 6,000.
You do not. You do. There is no way.
I know, I don't. I'm kidding.
Okay. Oh my gosh. All right. Okay. So some people in the chat, I personally love this exercise. I think it's like really fun to it's pretty meta to do like analysis and projects about your own R installation. And so I will kind of walk through the solution. I have this here. Some of the numbers of packages that people are well, first of all, let's start with libpaths. So where are we looking for our package installations? I have one option that shows up in my libpaths, which I have set. Did anyone have more than one option, or did everyone just have one libpath? LibS2. Was that surprising to you, Libby, or did you know that? You knew that? Okay. All right. Okay. Well, if you want to talk about maybe strategies around it, there are things we can do. Yes, having more than one libpath can cause confusion, and it can also kind of create a separation of church and state as well. If you want to keep some libraries, packages in certain libraries, it can be helpful for different reasons. So for example, if you are using Renv to control your package installations on specific projects, there is a separate place where Renv packages are installed. So you would see a Renv libpath as well if you're in a Renv project. Your default library is going to show up in .library, which is going to, for me, looks the same as what you see in my libpaths, but you could, again, have more than one libpath supplied and only one default library. And there's a little bit of interesting notation, like shorthand notation going on with a tilde here, but these are, in fact, the same. And the way you can do that, figure that out, is to wrap those paths in an FS function called path real. We'll get to FS later in the talk. And so if you wrap those paths in path real, you'll see that they are indeed actually the same path. So the way you're going to look at your installed packages is you could just grab it by install packages, and then you can pipe that into AsTable and create a data frame of all of your installed packages. And so I have 263 packages. And if I go back to the chat, I have people saying 395, 271, 555, 193. 262. So there's some variation in the number of packages you have out there. So you can do in row to figure that out. And then there's lots of features on these packages you can explore. So where that package is saved, the version of the package, something called priority, depends, imports, a lot of interesting metadata about your packages. So we can look at the priority of your packages. And like we talked about a few slides ago, 14 of them are base packages and 15 of them are recommended, and 234 I have just chosen to install for general use. What proportion of packages need compilation? So for me, that's about 40% of my packages need compilation. And I guess if you got down to the reflection, maybe you can drop in the chat, like what you learned about your R package installation or what you're curious to know more about. And there's some additional exercises here to kind of look at package naming conventions, like package names, like used to have periods in them often. So I only have 7 packages with a period in the name. And there's other options you can supply to install packages. So did anyone have any comments on what they learned or what they want to learn? There's no such thing as too many packages. It's about 555 is a perfectly fine number there. Yeah, just means you're exploring a lot of the ecosystem. $6K is not impossible, just unlikely, especially given that anytime you update R, you should really be starting with a clean state of all of your package installations. So if you just did a major upgrade to like 4.0.0, you really should have all of your packages newly installed. So I would imagine on if someone was on 4.9 and they haven't like fresh installed packages in a while, then yeah, they would probably have a lot more packages around, but 4.3 is relatively young in the package space, or in the R space. Okay, so if you are used to working in R projects, this might have felt a little weird to you, because this was a directory and with a collection of files that you received when you did use course, but you actually didn't receive a proper R project. So you can see here, it says R project none. So we are not in a proper RStudio project. And these are just the files in the directory, and I had to manually navigate to kind of find where these files were on my computer. So next we're going to start talking about how we're going to migrate this to a proper RStudio project and some of the advantages of that. So we're going to talk about adopting a project-oriented workflow. I guess in the chat, you give me a never if you've never used our projects. Or can you give me a thumbs up if you do use our projects? Never or thumbs up. RStudio projects, I should say. Okay. I am so excited. We have one person in this crowd who has never used an RStudio project, and this is going to be life-changing for you. I hope you can take this and move forward with it. And for all of you that do actually use RStudio projects, I hope that you get a little bit of a deeper understanding of like what's happening and why it's a good thing to use. So my mantra is friends don't let friends work in R without RStudio projects, because they make your life so much easier. So we're going to work on a project-oriented workflow, and this is going to really allow you to work on more than one thing at a time, to collaborate and distribute those projects, and to start and stop much easier. And the way this is achieved in an RStudio project is we're using the word project with capital P project. Like, this is a thing. I'm not just talking about project in like the loose sense of like, oh, we're going to work on a project. Like, RStudio project is a concept that RStudio facilitates and creates additional files for to make things workflow smooth. And the way this works is that you get a dedicated directory for your RStudio project. And other content in this workshop, and the 2-day workshop is related to having a Git repo as well, and adjacent to your RStudio project, or in conjunction with. And other concepts related to using RStudio projects is that we are not going to be setting our working directory. So I'm not going to name any names, but maybe the person that said they're never used an RStudio project, maybe instead you use something called like setwd to set a working directory for where files may be located relative to a project that you're working on. Or you will also often in older scripts see rm list equals ls, which is going to remove all objects in your environment. So an old quote from this is, if the top of your script contains these lines, Jenny Bryan will come into your office and set your computer on fire, because there's better ways to work. If you want to go down like the fun rabbit hole of the history of this quote, there's a few links down here. Why don't we just open up Twitter? Let's see here. 2 things that make Jenny Bryan mad, use projects with here instead. And there is a long list of replies to when this quote was born. There's an article, a blog post on workflow versus script as well. Oh, nice, Janine. Janine said she was there when she said that. It must have been a great moment in history. So if at any point you have like further questions or things you want to know about, like why set WD and RM might be practices, hopefully we'll not favored practices, hopefully we'll get to this, but if we don't, feel free to ask in the chat. And the good thing about project-oriented workflows is they kind of design this artifact away that users used to use set WD or used to remove items from their workspace. So with project-oriented workflows, we don't have to do this anymore, and we can work in a happier place. And one of the motivations for this is, let's do this exercise where we think which persist after we do RM list equals ls. So if you haven't seen that before, I'll just show you real quick. So note that like I have an object in my environment. So RM, I don't even use it. So what's the syntax here? List equals ls. So note that after I execute this line, my environment is going to be empty. So that's all it does, is it clears out all of the items in your environment. So let's go back and think, which of the following things are going to persist after we do that? So for each item, I want you to think like, will the effects of library dplyr persist? Will creating an object called summary and assigning a value of head persist? So which of these items are going to persist? Yes or no? If you want to be brave, you can write in the letters in the chat of the ones that you think persist. And otherwise, I would just give you a couple of minutes to think about it to yourself. Feel free to type your guesses in the chat. All right, so I hope that made you think a little bit about what the RM function might be doing, and hopefully I also gave you a hint. And when I said it just simply removes objects in your environment. So summary is created as an object in your environment, and the vector X is created as an object in your environment. And so when you remove these objects from your environment, no, they will not persist. So B and E are the only ones that do not persist. But everything else does persist after you execute RM. So like attaching a package will persist, setting an option will persist, setting a language will persist, an environmental variable, and attaching a data a package will persist. So all of these will persist after you execute RM. Which makes it tricky to kind of debug things. If you're in the habit of using RM, it makes it tricky to debug things when things go wrong, because there can be these invisible things happening in your environment that you aren't aware of, but can really interact with your project in unexpected ways that can lead you down a rabbit hole of trying to figure out what's actually going wrong here. So a better way of working is to kind of avoid that set WD and that RM business, and to work in an RStudio project. And what does it mean to be an RStudio project with a capital P? This is a thing. So it means you're going to get a file called a .rproj file, which you never have to do anything with. It's just RStudio's way of recognizing that you have declared this directory to be a project. And every open project that you have has a dedicated instance of RStudio, which means it has its own dedicated R process. It's got its own file browser pointed at the project directory, and the working directory is set to that project directory. Which means like you never have to use setwd if you're working in a project. And so this is kind of an illustration of what might happen for better or worse. You can have many projects open. So each of these R bubbles here represent a different project. And each project in parallel it's going to have its own directory, its own sort of version control set up, its own GitHub remote, and its own dedicated R process for each of these individual projects. So it makes it really easy to hop back and forth between projects, to open, get started quickly, close it, and move on. One really important concept of project-oriented workflows is the advantage of using something called a blank slate. So oftentimes when you're trying to figure out why things are going wrong in R and you need to go through a debugging exercise, the best way to do that is to restart R. And restarting R, when we're talking about what things persist, if you do a proper R restart, none of this, I don't think, will persist. I might need to double check that. But for the most part, none of this, yeah, I don't think any of this should persist after you restart R. So it's really actually giving your project a true blank slate when you're trying to debug what's going on line by line or why things are going wrong. And the way you can use a blank slate, like what a blank slate means is that when you restart R, like let's say I have this object called X in my environment. It's the numbers 1 through 15. So I have this object in my environment, and you know, just to show you, when I go to session, restart R, that environment is now clear. So it's clearing everything out of my environment like RM does, but it also does so much more than that, like removes all, like no packages are attached anymore or anything like that. And that's a special setting that you need to enable in your instance of RStudio. So it does not come enabled out of the gate. So I'm going to open up Tools and Global Options and show you what that looks like. So Tools, Global Options. And so if you've never looked at this file and if you've never thought about having a blank slate, you probably have this box checked. And you probably have this box say always. So we want to uncheck restore our data into workspace. So we never want to restore that. And we never want to save our data on exit. And that's going to allow us to restart R with a blank slate, which is a hugely important component of project-oriented workflows and debugging quickly. Equivalent way of doing that is using this use this command, use blank slate. I do want to let you know though that this is a lifestyle change. So if you're used to opening up R and having like a lot of objects in your environment, as soon as you open up R, like those objects aren't going to be there. If you close R and open it up again, like you're going to be starting literally with a blank slate. And I want to convince you that's actually a good practice, because it's going to force you to make your code more reproducible. So if you didn't like it, you should have saved, like if you like it, you should have saved the source code for it, right? You shouldn't be like holding on to these things that are in your R environment and afraid to restart R, afraid that they disappear. Like you really want to make sure, force yourself to have the discipline to write the code to save those objects. And I totally agree. Yeah, Livy, that it can be a little scary at first to do this lifestyle change, but I encourage you to do it now and you'll never look back. You're going to thank yourself for it later down the road. And so a really important concept of working within projects is to restart R often. So like anytime you install a package, like you're working on your data analysis project and you're like, oh, I want to see if this package is going to meet my needs. Anytime you install that package on the fly, you want to restart R to give it a little kickstart. Anytime things are getting buggy and feel wrong, you want to restart R and see if that bug still persists. So you're going to want to restart R often. And there's two different ways you can do it. You can go to Session, Restart R in the point and click menu. Or you can use some keyboard shortcuts. So on Windows, it's Control Shift F10. On Mac, you might use Command Shift 0 or Command Shift F10. And there's two different ways you can, or ways you might be going about making a project. So you might have a new folder that you want to make into an RStudio project. So you're just creating a new directory and a new project at the same time. So you're going to use this, create project, and then call it to whatever you want. Or you can also navigate to that, achieve the same thing by doing File, New Project, and it will give you some options there if you navigate through the point and click menu. So new directory, existing directory, or version control. And alternatively, you can make an existing folder into an RStudio project. So again, you can use this create project, the same exact function, but a directory that already exists. So in this case, this would be like our rstats WTF libraries one. Or you can navigate to that by doing File, New Project, and then clicking on Existing Directory, like as shown here. So I want you to just try option 2 now for the directory you just downloaded for Explore Libraries and create a project for it. Give me a thumbs up when you're done. All right, so I'm going to do that exercise myself now, and I'm so excited for the one participant who admitted that they've never, or shared that they've never used a project before because they said they just did it for this exercise. I got the thumbs up from them, and so someone's using their first project right now. It's very exciting. Okay, so I am going to go. I will exit this menu just so I can do it over again. So I'm going to go to File, New Project. It's going to say, do you want to do a new directory, an existing directory? Well, this directory already exists, so I'm going to do an existing directory. I'm going to figure out where I have this saved on my computer. It's right here. And this is the directory I'm going to convert to a project. I'm going to click on Create Project. And now all we're doing is converting this to a proper RStudio project. So you're going to notice a couple of things have changed in the directory before that weren't there before. So before, if you remember, when you looked at my R cube up here, it said like no project or project none or something like that. And now it actually has the name of the project here. And what's really nice about that is if you click down on this, you will see all of my projects, like not all, but like my most recent projects that I have worked on. So I've worked on a lot of WTF projects and then some work projects as well. Another thing that you'll notice about this is that some new files were created. So a couple of new files that are here are this .rproj file. That's just notes to itself for RStudio about your project that you never need to touch. And this rproj user, again, notes to yourself, to itself that you never need to touch. So those have been created for you. One thing that might not be super powerful to demonstrate in this project, but just if you haven't played with it, this R cube here is really, really handy. So it doesn't do anything for this project because everything's kind of flat on the same level, but maybe we can play with it in the next exercise. So you can see it navigates back to your top level of your working directory when you click on that R cube. Super powerful and handy. All right. Are there any questions before we move on to how we are going to take advantage of projects to construct safe paths? All right. So we're going to get into some deep thoughts about paths and how we make paths. So we need paths to access data. We need paths to create locations for where deliverables like exports or figures are saved, right? Like a data analysis, you're going to need to make paths. But there's better ways to make paths than others. So this was a tweet in 2022. There was a paper about whether our files on the Harvard Dataverse are actually reproducible. Most immediately, errors could be avoided if they worked with something called RIMF, and B, avoided hard coding file paths. Do not use setwd. So setwd is an example of a hard coded file path, and we'll show you ways to work around that and avoid it. And there's the link for this paper as well. And sometimes it can be like really tricky to navigate where your files are, especially in relationship to your working directory, and all of that kind of whittles away if you take advantage of your RStudio project. So we were going to want to practice safe paths. And what I mean by safe path is that it's relative to a stable base, and that you use file system functions. So we're not going to be using like these character operations like paste and string split to construct file paths. We're going to be using proper functions that do this well for you. So one package that you should be aware of is the FS package. and that is for file path handling. And another package you should be taking advantage of inside of your projects is the here package. So here is for project relative paths. So again, if you're working inside of an RStudio project, the here package is really, really handy for you to navigate directories inside of your RStudio project. On the other hand, if you want to kind of reach outside of that RStudio project, and do other things with your directories and paths, I recommend using the FS package. So we are going to look at examples of a stable base. So if we have a project directory, the here package represents way to create a path. Is an example of a stable base, because wherever that project is located on someone's computer, it's automatically going to be navigating to the top level of that project directory. So here are two equivalent ways you can specify a path using here. So data, comma, raw data CSV, it says go to the data subfolder or subdirectory and find the raw data.csv file, or you can alternatively and equivalently specify that as data slash raw data or CSV. Another thing that you should know, and hopefully I can remember to illustrate this later, is that when you are typing out file paths this way, you can automatically complete paths with tab. Another example of a stable base is a user's home directory. So if in case you did not know, all users have something called a home path, and they actually have a path home for R as well. And so that may, depending on your operating system, that may or may not be the same thing. So if we look at FS path home, there's my home path, and there is my home R path. I think if you're a Mac operating system, it's probably going to be the same thing. On Windows, it is different. But those are both examples of stable bases because they will be the same for each user respectively. And you might also have a stable base, which is like some official location for installed software. And if you want to really dig into the details of that, I would recommend reading the Gapminder README. So there's nothing wrong with absolute paths. I certainly use them all the time to kind of figure out where my things are, but I don't hardwire them into my scripts. So I'm going to form them at runtime relative to a stable base. So for example, a bad path might be something hardwired like user Shannon temp test CSV. But a good path would be something that's relative to a stable base. So if users Shannon is my home directory, then I can then take advantage of FS path home to then go into the temp test CSV file. So it's a small change, but it allows you to have that path and not be hardwired and computer or user specific. So that if you're collaborating with yourself on different computers, or if you're collaborating with other individuals, these objects should be accessible without having to touch the paths. So here is an illustration by Allison Horst about the here package, kind of showing you to follow the yellow brick road to get to the land of Oz, and seriously, just find your data. It's here. Promise. So what this does is it builds paths inside of a project. It's going to leave the working directory at that top level at all times during development, and absolute paths are going to be formed at runtime as you are executing things. And we'll take a look at an example of this. And one of the beautiful things about using here, like if I'm using saving an object like here, I'm saving it in my figs folder and I made some bar chart. It's going to work on my machine. It's going to work on yours if we're sharing the same RStudio project. It's going to work if the working directory is in a subfolder. It's going to work for RStudio projects and Git repos, and it's going to work importantly with Knitter and R Markdown as well. And that would also hold true for the newer Quarto file types as well. So the here package is designed to work inside of a project. That could mean probably you're using it in an RStudio project. It could also be a Git repo. It could be an R package. It doesn't have to be a proper project. It could be a folder with a file named .here. Just a quick note that here does not create directories. That's your job. It's just finding files and locations. And before we get into our next exercise, I just kind of want to distinguish between 3 types of paths here. So we do have like an absolute hardwired path. So like I'm looking at what you're going to be working at next, the WTF fixed paths project. We can also create paths relative to a working directory. And then that RStudio project does establish that working directory for your project. So note that read CSV here works the same as my hardwired path if this code is executed within my project, because your RStudio project does have the concept of a working directory. So it's going to go into that project working directory, into the data folder, and find your installed packages.csv. Instead of leveraging that default working directory, we could also leverage the relative path within the RStudio project directory. So we could use here in front of that. And again, that's going to be pointing to that RStudio project directory instead of that working directory in that instance. So all 3 of these paths will work equivalently. They're just 3 different ways of specifying them. And you're going to learn a little bit more about the nuances in the next exercise. Oops. Oh, okay. There we go. So it's your turn now. You're going to practice calling here in a project to get a feel for it. You're going to be doing use course, rstats -WTF, WTF fix paths. It's a slightly different setup than before. Again, if you're using use course, you can specify where that gets saved using the dest-dir argument. I'm going to just open up this GitHub repo real quick for you so you can see it. Instead of choose your own adventure thing, there is in the R directory 3 different exercises for you to complete. So 1 is path scripts. Then 2, if you have Quarto installed, you can try the Quarto working directory. If you're not familiar with Quarto and you know R Markdown, you can try the R Markdown working directory. And then the same thing for option 3, paths with Quarto or paths with R Markdown, choose your own adventure too. But I do want you to work through all 3 scripts. So script 1, script 2, script 3, just choose whether or not you're working in Quarto or R Markdown, or if you have questions about what those things are, you can drop them in the chat as well. Just to go back to the README real quick. So you're going to have a data folder, which contains data, an image folder, which contains images, and an R folder, which contains your scripts. And remember to restart R as indicated. So session restart R, or use your command shortcuts. And if you want to sneak peek exercises, those are in the link as well, but try not to challenge yourself. And of course, I will be on the chat if you have questions. All right, so hopefully everyone got a flavor of this. I'm going to open this up and walk through the exercise. I am going to use course. Let's see here. And I'm fine with that location. So yeah, I'm fine with deleting that. So yeah, that's good. And it's opening an RStudio project. So I just kind of want to illustrate some of the beautiful properties of working inside projects. So one is that, in case hopefully you can see, I now have two different instances of RStudio open, and it's two separate projects side by side. So you can look at your fixed paths project, or you can go back into your Explore Libraries project, and you can have both of them open, and they can both have their own project directory, their own working directory. I could have as many of these RStudio instances open as I care to. And another thing that also, if you want to limit the number of RStudio instances that you have open, you can also quickly switch back and forth between projects by toggling them in this path. If you were exploring this directory, if you're like, hey, what's in the R script? I'm not sure, and you want to go back up to the root of your directory, that's where your cube comes in really handy. So you just click on this R cube, and it's going to take you back up to the top level of that project directory immediately. It doesn't matter like how deep you are into your folder structure. And so one thing you'll notice here is that we do have data set up in a data folder inside your project directory. And that is a recommended practice to have all of your data nested within a project if possible. We can talk about alternatives if it's not possible. I'm going to open up the first R script where it says do not modify the working directory via set WD, and we're going to restart R often. So it says to modify the code to import to the data using absolute paths. So for me, I think that this is going to be because I have this saved somewhere else. Oh boy. I gave it some really crazy name when I used use course. So let's see here. This is the name of my directory now, I believe, and then I'm going in the data folder and the installed packages. So that was quite a feat to get that full path in there, but I actually don't have to use that full path. And I believe this data is from Ginny Bryan's older R installation where she first ran this project, and you can see she had 874 packages. Yes, she definitely wins for the number of installed packages. Now you can also set a relative path using your working directory. So that's established by your RStudio project. And again, so our data is located inside of our data folder. So I could just modify this by saying, let's go into our data folder. And again, we have our data read in. And again, you can see we've got 874 packages. And now we're going to modify this code using the here package. So I'm just going to write here, wrap that up. And then you can either write data slash, or you can do data comma, will work equivalently. And that's another way of reading in the data. So 3 ways of specifying the paths, but kind of leveraging different things. So again, this one is leveraging your working directory, and this one is leveraging your project directory. And hopefully the difference between those things becomes clear in the next exercise. So did you all do the Quarto or the R Markdown version? Any notes? They're the same, just slightly different. Oh my gosh. Once you've learned about the cube, it's like life-changing. You have to know the cube. Okay, well, let's do Quarto. Because in case you don't know about Quarto, you should know about Quarto. I believe Quarto now ships with your RStudio installation. So I don't think it's a separate installation anymore. It is a scientific communication documentation platform that allows you, similarly to R Markdown, to integrate code and prose and explanation at the same time. So this is a Quarto document. And what it says here is to kind of predict what are the things you're going to see. So what do you think your working directory is? What do you think it's going to be if you say, like, set it one level up from where I am, and then you get that working directory again, and what do you think it's going to be if then you check that working directory one more time, like, did it change? So let's go ahead and render this document, and you may or may not have gotten some surprises here. So my working directory is where this use course directory was saved. And my working directory for this Quarto document is the R subfolder of that project. Now, if I want to set my working directory one level up and then get my working directory again, it's going to be like the root of my R project that I've established, not that R subfolder. But then when you go to a new chunk and you say, well, let's just check one more time what my working directory is, you are back into your R subfolder. And hopefully for some of you, this clicks as to why using the here package is so important when using R Markdown or Quarto documents, because it allows you to access your project root, not whatever your R Markdown or your Quarto document considers to be your working directory, which is the location of that R Markdown or Quarto document. I know that was a mouthful, so if you have questions, you're certainly welcome to pop them in the chat. And then the last exercise here, it's just to kind of fix some paths up, again, using a Quarto document. So I have some absolute paths that I want to fix up. I'm going to be lazy and copy this from here. So I think that was it. So now I'm going to, that's my absolute path for this project. And then I want to do a relative path, leveraging my working directory. Again, my working directory for this is, I believe I need to go up one and into the data folder and into installed packages. I think that's going to work. Maybe not, maybe I typed that in wrong. Maybe I will cheat and look at my solutions. And then it's pretty easy if you use the here package. So here, this is going to be data, and then install packages, which is going to point instead to your project directory rather than your working directory. If I go back and click on my cube, I will find my README very quickly, where I can find the solution in case I am putting things in here wrong. So on exercise 3 //data // I thought that was going, oh, because it's fine. It needed to be knit. It was the right thing. It's just the working directory is different when you knit it than when you run it chunk at a time. Okay, I think this is all going to work. And I need one more thing here. Okay, so let's render this. All right, so we've got our absolute path. That worked. We've got our dat2 where we didn't use it. We went up a folder outside of R, then back up to our main level project directory, then into the data folder, then into our install packages. And then we also leveraged here instead. So hopefully that helps you to understand better the advantages of using the here package to find data or files relative to your project directory. Any questions? Yes, I think I agree, Livy, that when I first learned this, I was like, yes. And I think one other person commented, life makes so much more sense now. I understand where things are trying to pull from. Any questions about this? I know I've been talking for a while. We do have 25 minutes left. We can use 5 of those minutes for a stretch break, or we can keep powering through. I'll let you all throw it in the chat. Stretch break or go on, carry on. All right, sounds like a couple of people might have leveraged the break time, the activity time to do a stretch break. So if there are no super pressing, give me a break, I'll just carry on. We only got 25 minutes left together, people. All right. So I just showed you an example of a project structure where your data lives inside of that project in a dedicated data directory or data subfolder. And there is inevitably this question of like, what if, like, my data, it just can't live inside of my project directory. And there's lots of good operational and business reasons why it can't, but I would just stop to think first, like, are you sure? Are you sure it can't live in inside of your project? And if not, you might be able to find some tips in the Good Enough Practices paper. You can also create a symbolic link to access the data using FS functions. Depending on like how often your data changes, you could consider putting the data in an R package. You could use the pins package. There's also all sorts of other data warehousing options where you might need a proper database, data warehouse for your data. There are some related RStudio community threads that are linked down there below. And I would say there's also ways of creating stable bases relative to network shared drives as well, if you need to do so. I recently I feel like I saw a blog post on it in the past year about that, and I can't find it. So if you happen to know what I'm talking about, please send it my way. All right. So we've talked about using RStudio projects and creating safe paths with stable bases. But another aspect of project-oriented workflows is what you name your files, and names do matter. So here we go with some deep thoughts. Here is a quote from Romeo and Juliet, and this is not my own thought. This comes from Daniel Navarro's Project Structure Slides. And here's the famous quote from the play, and it says, "What's in a name? That which we call a rose by any other name would smell as sweet. Doesn't matter what we call it, it would still be sweet." But that is not true for file names, right? It absolutely does matter what you name your files. And the ways in which names matter is you want your file names to be machine readable, you want them to be human readable, and you want them to sort nicely. So I will give you 1 minute and maybe you can drop some thoughts in the chat. What features differentiate the sad names versus the happy names? All right, so there are a lot of ideas in the chat. So people notice that the sad file names have spaces in them. There's some special characters in them, that numbers are not padded by having a 0, inconsistent capitalization. And also someone commented on the date formatting. And also someone is commenting that unless you're a programmer, you might not know like how terrible these things are to programmers. So it's also, I certainly have given a talk at my all company meeting, like about what a good file name looks like. And for ideas to take back and incorporate into their daily practices. So you might have to do some education as well. So let's talk about names machines. Like 1, don't leave white space. 2, use letters, numbers, hyphens, and underscores. That's it. So characters can have a special meaning. And be consistent with case, because like not only just for like a readability aspect, but actually it can affect be impacted by your operating system. So some operating systems will treat a lowercase a and a capital A same, and some will treat it differently. And also this can get like a little bit in the weeds, but consider using separator characters wisely. Like you can use an underscore to separate different chunks, or a hyphen for words in the same chunk. And this is going to create names that are like friendly for regular expressions and easy to compute on. So beyond names that machines like, there's also things that make names human likable as well, right? So there was comments on this about the context in the chat. So a name contains information on context, on the content, and it can anticipate the context. You want to think about the concept of a slug from URLs in order to kind of create this abbreviated but readable context with a concise, meaningful description. And you'll usually append that to the end of your file name. And then the last aspect here is names that sort nicely. So things are going to sort nicely when you have something numeric in your file system, like maybe there's a natural ordering for your files. I would recommend left padding zeros with zeros for constant width. So instead of writing 1, you might not anticipate you're going to make it up to file 10, but you probably will end up making it to file 10 and regret it when you have a 1 through 9 and then a 10. So you want to pad those with zeros for constant width to get things to sort nicely. If you haven't heard of the ISO 8601 standard, please start using it now. I don't have the link for it in this slide, but I should. Maybe it's on the next slide. It is actually, and is it in here? Yes, it is here. This is an international standard. So you can use this as an argument for how dates should be formatted. So it is unambiguous and international to do the 4-digit year, the 2-digit month, and the 2-digit day. So it is an international standard for date conventions. So, am I still on Zoom? Yeah, okay, all right, cool. Yeah, are you still seeing my slides? Okay, okay. Are you seeing this message?
Sorry, no, we're not seeing your slides, we're seeing
We're not seeing your
your
slides.
browser.
I'm here, I'm back again. I don't know what just happened. Okay.
Yeah, we can see you.
All right. I will screen share again. Okay. All right. Okay. So I love Jenny Bryan's commitment to ISO 8601 dates. She's got an unwavering commitment. People of all nations can parse her freezer. So there's her chicken stock and ISO standard date formatting. So if you have these kind of good file names that maybe have left padded prefixes for something numeric and that provide context or content about what a file does, it makes it pretty easy to kind of search through your files. Like maybe you want to use this function from the FS package called dir_ls, which will show you all the contents, list out the contents of a directory. And this time it's showing it for this feature that has a .r ending. And what's nice about this is that anyone can guess at the file's purpose. So you don't really have to have this complicated README that gives like overly verbose instructions on how to actually dive into your project. And also they're easy to filter on, right? So you can like detect, like search for certain keywords. And then if you use delimiters intentionally, like underscores versus hyphens, then it can be pretty easy also to kind of create some metadata about the files that you have. And then if you have something in numeric in there, it will also sort in the same order as you experience in real life. So names matter. You want them to be machine readable, human readable, and sort nicely. And this is something that's really easy to go ahead and implement now. And it will certainly pay off for yourself in the future. And also as you're collaborating as well, it makes it easier to jump in and out of projects. All right. So we will spend our last few minutes here talking about some recommendations for project structure, which you got a little bit of a flavor of in your last exercise where you had that R folder for your R scripts. You had a data folder for your raw data, and you had an image or a figure folder for some output figures. So you really want to be aware of like monolithic projects that just grow and grow. And you want to break down the logic and output into pieces, having like more than one script. And a way you can kind of think about this is a workflow from the R for Data Science book about like the process of data science. And we can kind of break down these processes in terms of our projects as well, this iteration. So if we can think about like the different steps we take to create and execute a project, these are like, it can be challenging, but you can put them into modular steps, like maybe some wrangling, some modeling, some making of figures or creating a report. And any way that you break that down is just, it's gonna be better than one big script with everything.r. Like it doesn't matter how in the weeds you get into breaking it down is still better than everything.r in one script. And so maybe when you think about breaking it down, you might have like you're importing separately from your tidying of the data, from your modeling, from your figures, and from your report. And so these different scripts are kind of aligning with different aspects of your data science process. Of course, it doesn't have to be this like project structure exactly. This is just an example. And then there's also data artifacts. So you might have some raw data, you might tidy it and put it, clean it, and then you might have some clean data, which is like data.csv. You might do some model fitting, which would be saved as fit.rds. You might get some coefficient estimates and save those down again. These are all different artifacts you could have from your project. And again, saving these individually is much better than having like one massive file of our data where you're not sure what's in that file, how it got there and how it came to be. It makes kind of like making small tweaks and modifications complex. And so in terms of your process, like each process might be associated with an artifact itself, right? Like, so an importing might be associated with raw data, your tidying might be associated with data, your modeling is going to be associated with fits. And then when you're visualizing, that's going to go into some figures that you create as well. So there's these artifacts that come out of your project. And so one way you can think about lining up your project and breaking it down is think about what goes into your code, the code that you're using to like kind of work with that object, and then what comes out as a result. So for example, you might put raw data into wrangle.r to kind of get your data into shape, and you're going to come out with some clean data called data.csv. Then that data.csv is now going to be used as an input for modeling. And as a result of running model.r, now you're going to get some model fits and some coefficient estimates. And then with those things, those now become inputs into your next thing where you're making some figures, which go into your figs output. And all of this might get wrapped up into some larger report that you're generating. And you're getting some sort of report output as well. So things kind of line up between your input, your code, and your output, and they build sequentially on top of each other. So the last exercise that we have, which I suspect we might be better off leaving it to the reader to do on their own and using their time to wrap up here and answer any questions, is to create a report that adheres to project organization strategies. So you can again do use course, RStats, WTF packages report. I can just talk you through it real quick if you're kind of interested in doing it on your own. You want to look around the files and see where's your data, where's your figure, where's your R scripts. Open each R script, finish it, run it. Remember to restart R as you go, and kind of build up a package, a project as you might in terms of like exploring your R packages. So importing the data, creating the data, doing some wrangling of that data, and creating some figures of it. And I think I will pause there and take questions and discussion for our last 6 minutes. I'll do a couple of questions on recording, and then we can go off recording if people want to ask any questions off recording. So there is one question in the chat. It says, what do you think about using a Quarto file for wrangling data instead of an R file? I think that's a really great question, and also something that I have thought about before. So one very strong advantage of using a Quarto or equivalently an R markdown file is that every time you render that file, you actually are, by default, are starting with a blank slate. So it does enforce your code to be very clean and precise, and it kind of can help you eliminate confounding factors in your debugging process. So sometimes it can feel like overhead that is unnecessary, but also it allows you to put in like nicer and cleaner notes when you're talking to yourself about what your project or your cleaning script is doing. So I do think using a Quarto or R Markdown file for data wrangling is like has huge advantages. Are there any other questions we want to talk about on camera?
Yeah, Shelley, do you want to go ahead and stop the recording? Then we can take questions after that.